Okay, so I'm doing a quick video on forces in covalent bonding. So I'm just going to go straight to this example here and try and explain it in terms of the example we've got. So a Lewis dot diagram of a CF4 molecule, so that must have one carbon, and carbon has 4 unpaired electrons. And we need 4 fluorines, and fluorine has 7 unpaired electrons, which works really well paired with carbon because we just sort of get one fluorine on each side of the carbon. So the sharing of electrons here, that is what a covalent bond is. Covalent bond is the sharing of electrons. And that is a really, really strong bond. It's really, really difficult to break. So it's within each individual molecule, because this thing makes up a molecule. This is one molecule. And there's going to be other molecules hanging around it as well, but it's kind of one thing on its own. And the carbon and the fluorines are held together by really strong covalent bonds. Okay. So here we're looking at each CF4 as a molecule, a CF4 molecule. So they're all sort of floating around together. Now between the molecules we also have bonds. So these bonds, it's more sort of just an electrostatic force, I suppose. But between the molecules we have van der Waals forces. No, it should be a lowercase v, but whatever. Okay, what is that? So van der Waals forces between the molecules. And you don't really need to know how the van der Waals forces work or why they're there, but basically it's just because in every C4 molecule there's parts of the molecule that are positive, sort of a bit positive, and parts of the molecule that are a bit negative, just because of all the protons and electrons and so on. So we get some kind of electrostatic bonding between the molecules because of that. We call that van der Waals forces. Van der Waals forces are really weak. Like, that electrostatic attraction between the molecules isn't very strong at all. So it's really easy to break apart those van der Waals forces. So in summary of that so far, within the molecule, we have very strong covalent bonds. And they are also referred to as intramolecular forces. Between the molecules, we have very weak van der Waals forces. Which are also known as intermolecular forces. So you need to try and sort of remember that the covalent bonds are intramolecular and the van der Waals are intermolecular, which is tricky. The way that I remember it is I kind of think of the intranet and the internet, because the intranet is like within Rosny College. The internet is like between the colleges, or between the whole world, which is probably not the best analogy, but it helps me remember which is which. Okay, now we've just got a few questions. Describe the forces involved when water evaporates. So when water evaporates, when we've got water as a liquid, it's just a bunch of H2O molecules, and the van der Waals forces, or the forces between them, are strongish. So the molecules are held together fairly closely. When we heat up the water, the molecules get a lot more movement, and so they're not held together as closely. They sort of spread apart a bit, but the molecules still stay intact. They just move away from each other. So your hydrogen and your oxygen are not separating from the water molecule. It's just the H2O molecules separating from each other. So there's definitely no covalent bonds broken. It's just the breaking or the weakening of the van der Waals forces. Oops, why have I started with an H? So this doesn't require very much energy, which is why water evaporates slowly at room temperature and boils at 100 degrees, which is really not very high temperature, because not very much energy is required at all to break those bonds because they're so weak. So that's what's happening. It's a physical change. Let's add that. Physical change only. And the molecules themselves, they're not changing. What we've got happening is H2O as a liquid. We apply heat or even just time, and we get H2O as a gas. So it's still H2O, they're just more spread out, okay? All right, so the forces involved in water is broken down into hydrogen gas and oxygen gas, so that's quite different. So here, this is a chemical change because the molecule is breaking apart. So we've got H2O, and that's going to become, let's say it's a liquid, and we get H2 gas plus O2 gas, and I'm going to need to balance this like that. Okay, so the molecule's actually been broken apart there, so we've broken the really strong covalent bonds, which requires huge amounts of energy. Oops. Okay, in terms of bonding, why does oxygen gas have a low melting temperature? It also has a really low boiling temperature because it is actually a gas at room temperature, and it's just because of the weak van der Waals forces. Okay, that'll do, I reckon. And I'm pretty sure that's it. The next part on polar molecules I covered as like in class, but I filmed the lesson, so it's not quite as clear and concise as these videos, but it does sort of explain it okay-ish. So that's it for that. Cheers.